Hi everyone. So today we're going to do some review of the tutorial test that you wrote. Okay, so on the WhatsApp group, people asked me to go through some things. So we're going to go through questions H, I, and J. Okay, so let's start off with H. Okay, so we were given the function 1 over root x, and we had to rotate that around the x-axis from x equals 1 to x equals 4. So let's do a little sketch of that quickly. Okay, so we have y equals 1 over root x from x equals 1 to x equals 4. So this is our region, and we're rotating around the x-axis. Okay, so if we were to rotate this around, what kind of shape would we get? Well, this line over here, if we rotate that around the x-axis, we're going to get a large circle. Like that. If we take this line at x equals 4 and rotate it around, we're going to get a smaller circle, something like this. And then we connect it by this slope, the y equals 1 over root x. So it's going to be something like this. Okay, so that's the shape that we get. Okay, now we want to find the volume. So to find the volume, we need to know the radius. So if we just take a look at our shape here, if I draw the rotation axis there, the radius is the distance from the x-axis out to the surface. So that's the radius. So if we go back to our picture, this distance is going to be the radius. Okay, that is the y distance. Okay, so whatever the y value is, that's the distance there. So the radius is going to be whatever the y value is, okay, because it's the vertical distance, and that is given by 1 over root x. Yeah, and that's all we need because we're just using the disk method. So we just need one radius. So the volume in this case is going to be the integral from 1 to 4, because x goes from 1 to 4, pi times the radius squared dx. Okay, so that's going to be pi integral from 1 to 4. The radius squared is going to be 1 over root x squared. That's going to be 1 over x dx. Okay, so now the integral of 1 over x is the natural log of x. So the natural log, remember your absolute values. These are important. Okay, so we can't put negative x inside the natural log. So we have to put the absolute values. This goes from 1 to 4. So we end up with pi natural log of 4 minus pi natural log of 1. But the natural log of 1 is 0, so that goes away. So we're left with pi natural log of 4 units cubed. Okay, so that's how we found the volume given this curve. Are there any questions about this? Okay, so if you have any questions, please just unmute yourself or type it in the chat. Okay, so any questions about this one? Yeah, got a question?
Yeah, so may you please repeat where you put a natural log?
Okay, so the integral of 1 over x is the natural log of absolute value of x plus c. Okay, it's one of the integrals that we've covered before. Okay, so you just need to remember the antiderivative or the integral of 1 over x. Okay, it's somewhere in your notes at the beginning of the integral section. Okay, any other questions? Okay, let's take a look at the next one. That was question I. Okay, so let's see what this one was about. So this was very similar to the last one. So let's just draw a little sketch of what's going on. We had the same function, 1 over root x. Okay, but now we're not rotating it around the x-axis. We're rotating around y equals -1. So here's y equals -1. Okay, so we had the same thing as before, x equals 1 to x equals 4. We have y equals 0 along there. So here is our region. Okay, that is the region enclosed by all three of these curves here. So y equals 1 over x, 1 over root x, x equals 1, x equals 4, and y equals 0. So the intersection of all of these gives us this region here. Okay, and we want to rotate that around y equals -1. Okay, so what kind of shape is this going to give? Well, this line over here is going to give us a circle, but this bit over here is going to be cut out because we're not including that. Okay, so we end up with something like this. Okay, and then we've got a smaller circle inside. Okay, and then this goes down like this, and then we have the same thing on the other side. Okay, and then connecting it is this tube over here. Okay, so it's something like that. Okay, and then the line y equals -1, that goes right through the middle here. Okay, so that's our shape. Okay, so what we want to do now is find the volume of this. Okay, so now if we look at this, we need to use the washer method, because now if we look at the axis, we've got an inner radius and an outer radius. It's not a single radius anymore. So here, this distance here is going to be our inner radius. Okay, because that is the closer radius to the rotation axis. This larger distance here, this is going to be the outer radius. Okay, because it's further away from our axis of rotation. Okay, so we've got 2 of those there. Okay, so inner radius, how do we find that? Okay, so we're going from y equals 0 to y equals -1. So we can write 0 minus -1. That gives us 1. Okay, and then the outer radius is going to be 1 over root x. 1 over root x minus -1. So it will be 1 over root x plus 1. Okay, I've got a question here. The inner circle part confuses me, so please can I ask you? Is it okay to say the inner circle is the yellow shaded part? The inner circle is this part over here. Let's put that in red. So this part over here. So in red here, that is this section over here for our curve. Okay, that's in red. And let's put the outer part in blue. Oh, no, we've used blue. Let's use green. Okay, so we've got green here for the outer part. We've got green here for the outer part. Okay, so, and we've got the center line going through here. Okay, so we've got this distance to the red part. That is our smaller radius. So that's the inner radius. The distance to the green part is the larger distance. So it's the outer radius. So a smaller distance inside smaller distance R in, larger distance R out. Okay, so it's just the distance from the rotation axis, so from this axis over here, out to the surface. So if we move outwards, we are first going to hit the red line. So the distance from the axis to the red line, that's the inner radius. If we go out even further, we're going to hit the green line. So the distance from the axis to the green line is going to be the outer radius. Okay, because remember that this part inside here, this bit's there, that's empty. So we don't include that. We're only looking for the distance from the axis to the red line, that's the inner radius, and the distance from the axis to the green line, that's the outer radius. Okay, so there's two radii that we're interested in. Okay, does that answer your question? Okay, awesome. Okay, so we've got the inner radius and we've got the outer radius, and we're looking for this distance. How do we find distances? Well, we take the bigger one minus the smaller one. So we have at the top y equals 0 minus 1. So this distance is 1. That distance is 1. What about the outer radius? We're going to take the bigger y value minus the smaller y value. That gives us this distance over here. So it's going to be the bigger y value, which is 1 over root x, minus the smaller y value, which is minus 1. And the minus make a plus. So we get 1 over root x plus 1. Okay, so we've got the inner radius, we've got the outer radius. We now can substitute using that washer method. So the volume is going to be the integral from from 1 to 4, because we're going from x equals 1 to x equals 4. So that would be pi r out squared minus r in squared dx. Okay, so now we just substitute in. So this is going to be pi integral from 1 to 4. R out squared is going to be 1 over root x plus 1 squared. R in squared is going to be 1 squared dx. Okay, so this is going to be pi integral from 1 to 4. Let's expand this out. So 1 over root x squared, that's going to be 1 over x. Then we've got the cross term, so that's going to be plus 2, 1 over root x, and then 1 squared is 1. And then minus 1. So this and this go away, because we got plus 1 minus 1. So this becomes pi integral from 1 to 4, 1 over x, plus 2x to the minus 1/2. So I just wrote this as an exponent. Okay, so we can use the power rule, dx. So this becomes pi integral of 1 over x, that's the natural log of x, integral of 2x to the minus 1/2. We add 1 to the exponent to make it half, divide by half, that's the same thing as multiplying by 2. So we have plus 4x to the 1/2 from 1 to 4. So this is going to be pi, the natural log of 4, plus 4 times 4 to the 1/2, minus the natural log of 1. Or we can just write natural log of 1, minus 4 times 1 to the 1/2. Okay, so this is going to be pi, the natural log of 4, plus 4 times 2, that's going to be 8, minus 0, because the natural log of 1 is 0, minus 4. So that's going to be pi, the natural log of 4 plus 4 units cubed. Okay, so that's how we find the volume in this case. Okay, so let's go back to the picture here. Any questions about this example? Okay, let's just check the chat. Okay, no questions there. Okay, let's take a look at question J. Okay, so here we had y equals e to the minus 2x. Y is equal to e to the minus x, and this was rotated around the x-axis. Okay, from x equals 0 to x equals 1. Okay, so let's just draw a little sketch of what's going on here. Okay, so e to the minus x, that's going to look something like this. Okay, where it passes through 0, 1. E to the minus 2x is going to look very similar, but it's going to have a much steeper slope. So it's going to look something like this. Okay, so e to the minus 2x will go to 0 much faster than e to the minus x. So it's going to be underneath. Okay, so we have e to the minus 2x on the bottom and e to the minus x on the top. Okay, and this goes from 0 to 1. So we have x equals 1 somewhere over here. Okay, so this is the region, the shape over here, and we're going to rotate that around the x-axis. Okay, so what kind of shape do we get? Well, this point 0, 1, if we rotate that around the x-axis, we're going to get a circle, something like that. And then at x equals 1, we're going to get another circle going around. Okay, but we're going to get an outer circle and an inner circle because there's, you can see there's two points there. So it's going to look something like this. Okay, and then these are connected like that. Yeah, so it's going to be something like that. So it's like a funnel inside a smaller funnel, or sorry, a smaller funnel inside a larger funnel, if you want to think of it like that. Okay, so now we want to find the volume. So we're going from x equals 0 to x equals 1. We can see that if we rotate around the x-axis, we're going to have 2 radii because we've got 2 functions. Okay, the upper function here is going to be the larger radius. So that must be r out. Okay, this function over here, that must be r in. Okay, so we've got the upper function being r out. The lower function is going to be r in. So r out is going to be e to the minus x, because that's the upper one over there. R in is going to be e to the minus 2x, because that's the lower function in our picture. Okay, so we've got the outer radius, we've got the inner radius, we can find the volume. So the volume is going to be the integral from 0 to 1, because x goes from 0 to 1, pi r out squared minus r in squared dx. Okay, so we can take the pi out. So we have pi integral from 0 to 1. R out squared is going to be e to the minus x squared minus Rn squared is going to be e to the minus 2x squared. Okay, so now remember your rules with exponents. If you have an exponent to the power of an exponent, you multiply this inside. So we do that. So that's going to be pi integral from 0 to 1, e to the minus 2x, because we times the 2 inside, minus e to the minus 4x, we times the 2 inside. Okay, so now we need to integrate this. So we're going to have pi integral of e to the minus 2x is going to be minus 1/2 e to the minus 2x. Integral of e to the minus 4x is going to give us plus, because of the minus sign, 1/4 e to the minus 4x, evaluated from 0 to 1. Okay, so this is going to be pi minus 1/2 e to the minus 2, because x is 1, plus 1/4 e to the minus 4, because x is 1, plus 1/2 e to the 0, minus 1/4 e to the 0. Okay, but anything to the power 0 is just 1. So that and that, they're both 1. So we end up with pi minus 1/2 e to the minus 2, plus 1/4 e to the minus 4, plus 1/2 minus 1/4. Okay, and then half minus 1/4, we're left with 1/4. So we have pi minus 1/2 e to the minus 2, plus 1/4 e to the minus 4. Half minus 1/4, that's 1/4. So we have plus 1/4 units cubed. Okay. Let's go back to the picture. Any questions about this one? Okay, so this was question J from your tutorial quiz. Okay, are there any other questions about the disk or washer method? Okay, so everyone's all right with this. Okay, so next week's tutorial quiz, it was only supposed to be on the shell method, but I'm going to make it on the disk method, washer method, and shell method, just so that you can go over the stuff again and then maybe boost your marks for this section. Okay, so let's just make a little note here. So next week's tutorial quiz. Okay, so you're going to have one question on the disk method, one question on the washer method, and one question on the shell method. Okay, so that would be 5, 5, and 5. Okay, and then I will use these first 2 questions here to try and boost your marks from this quiz that we've had this week. Okay, so please go over this again, and then hopefully you can use next week's tutorial quiz to boost your marks with that. Okay, what about the previous topic, finding area between curves? We already did the quiz on that. That was on the 16th. I think we had that quiz on area between curves. So that's already been tested. So we're moving on to the volume stuff now. Okay, so please go over your stuff again. And then these two here, I will use to boost your previous marks. So please go over this again.
Oh, sorry, sir.
Yeah?
Yeah, the next week total quiz will be a summative or formative.
Formative.
Okay,
So you're not writing anything out to submit. It's going to be multiple choice like we had last week. Okay, but it will be on these three. So same style. Okay, so each question for 5 marks, similar to what we had this week. Okay, but then I'm going to include this disk method and washer method. So if you go over your stuff again and then do these two, then that should boost your marks for those 2 sections. Okay, and then 1 question on the shell method, because that's what we've been doing this week. Okay, any questions on this tutorial quiz for next week? Okay, so that's for next week. And then remember, the week after that, we have test 2. Okay, so class test 2 will be on the 6th of April. Okay, and that will be on the volume stuff that we've gone over and integration by parts. Okay, any questions on test 2?
Oh yes, is the area under the curve will be available on test 2?
Sorry, I couldn't hear you.
The area under the curve.
Okay. Yeah, let's just go. I'll get the scope now and then we can have a look.
Okay.
So I'll show you what's in test 2. Okay, let's see here. Okay, can you see this here?
Yes.
Okay, here we go. So here's your test content. So you're going to have questions on area between curves, the 3 volume methods. So volume by disk, volume by washers, volume by shells, and then average value of a function. That's a very small section we'll get to. And then integration by parts. That's a bigger section. Okay. Okay, so we'll cover that, all of that before your test 2 that's coming up. Okay, so it's this part in green here. This is the scope for your test 2. Okay, any questions on that? Okay, and then that's over here on the 6th of April. Okay, so we're almost done with this week here. We've got 1 week here to go over integration by parts, average value of a function. Then we will do revision, okay, on the 4th and the 5th of April, and then you write test 2 on the 6th. Okay, any questions on that? Okay, if you do have any questions later on, you can always email me or just send me a message on WhatsApp and then I can help you out. Okay, so tomorrow we will carry on with the shell method and then we'll finish that off and then we'll start with the new work on Monday. Okay, bye everyone.